Have you ever noticed a human arm and a bat wing have oddly similar structures? Or wondered how scientists know that birds evolved from dinosaurs? If you didn't know that before, you do now. Let's find out about how structures in fossils help to give us clues about evolutionary history. I'm sure you've heard of the word before, but what is evolution? Evolution is the change in traits of a population over generations, which could be years, decades, eons. The list goes on. What are homologous structures? Fancy term. Homologous structures are two pieces of anatomy of two different species that share very similar structure. Homo, same. Structure, same structure. Like the bones in a cat paw versus a human hand. The similarity in structure tells us that the two species have common ancestry. However, while they do share structures, they don't share the same function. On the other hand, we have analogous structures, which are the complete opposite of homologous structures. Their structures are different, like a bird wing has bones and a mosquito's wing has no bones at all. While their structures are much different, analogous structures share the same function. Like a bird and a mosquito both use their wings to fly, even though they don't have the same structure at all. The difference in the structure between the two species tells us that they do not have any common ancestry. Okay, yawn, I get it. We've talked about structures a lot. What about fossils? Fossils are cool, right? Well, transitional fossils are like stamps in the earth that tell us how a species evolved and when. Transitional fossils are fossils that show features from an older parent species to the newer descendant species. Scientists can find out when this evolution occurred by how deep the fossils were found beneath ground level, which is called a fossil record as shown here. There's other methods that they can use, like radiometric dating, but I won't get into that. Transitional fossils are very important in research and the study of evolution. They show how major evolutionary changes happened, for example, fish to amphibians and dinosaurs to birds. By comparing fossil anatomy with modern organisms, scientists build phylogenetic trees. The last thing I want to mention is the fossil that linked birds and dinosaurs, which is called Archaeopteryx. This fossil is arguably one of the most important fossils ever discovered because it provided strong support for Darwin's theory of evolution, and it changed the way scientists viewed things. Thank you for watching. I hope you understand how structures in fossils provide support for the theory of evolution and you enjoyed this at least a little bit. Bye!